Hello, welcome to my YouTube channel. In this video, we're gonna do a few questions from paper 3. So it's summer 17, paper 31. Okay, so let's have a look on the first question. So it says solve the inequality. So there are different methods we can solve. So here let's say we can square on both sides. We're gonna square here, we can expand the square, so you can just like simply expand, or you can expand using the FOIL method. So 3 times x minus 2 times x minus 2, so 3 squared as well. So here we will get 4x squared plus 2x plus 2x plus 1, and this will be 9 x squared minus 2x minus 2x and then plus 4. So from here what we will do, so this can be simplified to 4x squared plus 4x plus 1, and then this will be 9 times x squared minus 4x plus 4. So further simplify to this, so 4x squared plus 4x plus 1 is less than 9x squared minus 36x, and 9 times 4 is 36. So then here we can bring everything on one side, so this will be 9x squared minus 36x plus 36 minus 4x squared minus 4x, and then minus 1 is greater than 0. So here if we simplify this, so this will be 5x squared minus 40x and plus 35 is greater than 0. So this will be 8x plus 7 is greater than 0. So we can write the factors of this, so it can be x minus 7 and x minus 1. So which means the critical values are 1 and 7. So since you remember, like we had a quadratic equation, and this quadratic equation, so the coefficient of x squared was positive, so 1 and 7, these are the roots for this. So we will get a parabola like this. So since the inequality here is greater than 0, so greater than 0 means above the x-axis we have to choose. So here, so that means the inequality will be less than 1, or x is going to be greater than 7. Okay, then next question, question number 2. So in this one, it says expand 1 over cube root of 1 plus 6x in ascending power of x up to and including the term in x cubed. So we need to use the binomial theorem as we have learned. So first of all, we need to write this in a power form, so which is like 1 plus 6x whole to the power of minus 1 by 3. Because here, if I just add one more step over here, so this is 1 plus 6x, and because since this is a cube root, so it's 1 over 3. So once we will bring this up, so it will be negative 1 by 3 over here. So now when we apply the binomial theorem over here, so this will be 1 plus its nx, so n is what, minus 1 by 3, and x is 6x, plus n times n minus 1, so minus 1 by 3 times minus 1 by 3 minus 1 over 2 factorial 6x to the power of 2. Then plus n times n minus 1 times n minus 2 over 3 factorial 6x to the power of 3, because it says we have to include the term in x cube, so we need to write till 6x cube. We can just use a calculator to simplify this. So this will be 1 minus 2x, and then if we simplify this, so this will be 8x squared, and then from here we will get minus 112 over 3x cubed. Okay, so then let's have a look into the next question. Okay, question number 3. In this one it says it is given that x is equal to ln of 1 minus y minus ln of y, where y is greater than 0 and less than 1. Show that y is equal to e to the power of minus x over 1 plus e to the power of minus x. So since we have x is equal to ln of 1 minus y minus ln of y, so we can use the property of log, because we can see the expression we have to get it, so we need to remove the logarithms from here. So if we use the property, so this is ln of 1 minus y over y, because as you remember, like ln of m by y, so this can be written as ln of m minus ln of y. So from here, if we need to get rid of this log over here, so we need to apply exponential on both sides. So this will be 1 minus y over y, and then we have to rearrange it to make the y the subject. So y e to the power x plus y is equal to 1. So from here we can see we're gonna get like 1 plus e to the power x is equal to 1, which means y is equal to 1 by 1 plus e to the power of x. But if we look into the expression, so it has e to the power of negative x. So in order to do that, what we're going to do, we are going to divide by e to the power x in the numerator and denominator. So here, once we will do in the numerator, so this will be 1 over e to the power x over 1 plus e to the power x over e to the power x. Since we just have to prove, so that's why we are doing this one. So the top will be e to the power of negative x, because when we reciprocate this one, so it will be the sign of the power has been changed over here. Then here, so this will be 1 over e to the power x plus e to the power x over e to the power x, so which means e to the power minus x over, again this will become e to the power minus x plus 1, and we need to give the final form in e to the power minus x over 1 plus e to the power of minus x. Okay, so next part of it. The next part, it says, hence show that integral of 0 to 1 y dx is equal to ln of 2e over e plus 1. So we have to prove this one again. So we will take this side, so y dx, so then 0 to 1, as we just proved y is what? E to the power minus x over 1 plus e to the power of minus x dx. So we need to substitute the value. So we can see over here, because 1 plus e to the power of minus x is there in the denominator. So we need to integrate this one. So if we are integrating this, the denominator, so we have to have a derivative of this on the top. So you can see directly, or else you can use u substitution. So u is like, we can select our denominator, then du will be minus e to the power minus x dx. So that's mean dx will be du by negative e to the power of minus x. So if we replace the values over here, or directly we can make out of here, we can multiply and divide with the minus sign. So since we know the derivative of this we already created over here, so once we have a derivative of this we can integrate this directly. So this will be ln of 1 plus e to the power of minus x with the minus sign, and the limit is from 0 to 1. If you want, like, you can plug the values over here and you can see this will give you the same answer. So now we will replace the limits over here. So minus ln of 1 plus e to the power minus 1, and then minus and minus plus ln of 1 plus e to the power of minus 0. So this will be written as minus ln of 1 plus 1 over e, and we need to prove 2e over e plus 1. So here ln of 1 plus, so e to the power 0, so this will be 1, so this is ln of 2, so minus ln of 1 plus e, 1 over e, plus ln of 2. So we can use the property of log, so which will be 2 over 1 plus 1 over e. So here if we further simplify this, so this will be 2 over e plus 1 over e, and then third fraction will go to the first fraction, so this will be ln of 2e over 1 plus e. And you can look back, we have to prove ln of 2e over e plus 1, so we have proved this one.